So here we are looking at how to find and to calculate question to do with electricity. This is all of electricity in IGCSE. How to approach every question that can be asked. So let's dive in. So we have the find the combined resistance of the following network of resistors. If you can look at the connection that we have here, these two resistors are connected in parallel, but this one is in series with this two. So we are going to focus on the parallel part. So this is going to be 1/4 plus 1/2. Then you say raised to power -1, because anytime you find the sum of the reciprocal of the reciprocals, you have to find the reciprocal to find the final answer. And this one now will be +3. So anytime you have resistors which are connected in parallel, say 1 over the value here and plus 1 over the value of this, but you have to say raised to power -1. Then if there is this one that is parallel series, you are going to add it. So if you work it out using your calculator here, let's see what you're gonna get. That will be 1/4 plus 1/2 raised to power -1. That is going to give us 4/3, yeah, which is the same as 1.33. so this is 1.33, then we shall say +3, and that gives us 4.33 ohms. So don't forget to write the correct units anytime you are working out of a question like that. This one, you can see these guys here, that whatever we have here is in series. So it means that at that point we have to find the total of these two, which is going to be 6 ohms. Now the combination of these two will form 6 ohms, but it's going to, that 6 ohms here is going to be parallel with this one. So meaning we're going to say 1/6 plus again 1/6 here. And that is going to say we shall raise to power -1, then plus the one that is in series, which is 7 here. So if you work it out, 1/6 plus 1/6, that's going to give us 1/3, and the reciprocal of 1/3 is 3. So this is going to be 3 plus 7, and that's going to translate to 10 ohms. So we have a total resistance of 10 ohms for this connection. So one of the areas that you need to understand is to work out a combination of resistors. Also, you need to remember how to define the term potential difference. And this is, we're going to say, this is the work done. This is the amount of work done. Amount of work done to move a unit charge, to move a unit charge, to move a unit charge between 2 points in a circuit. In a circuit. So the amount of work done to move a unit charge between 2 points in a circuit is what we call potential difference. So for instance, in the event you have maybe 6 volts here, which is a cell which is supplying power, then we have maybe an ammeter, at this point. Then next here, let's say we have a resistor at point P and point Q. So the amount of work done to move a unit charge across the resistor is what we call the potential difference. And in the event you are expected to measure the PD between 2 points of a given component, you are going to connect a voltmeter shown there. That's how you connect a voltmeter. A voltmeter is always connected in parallel with another component. But electromotive force is the work done to move a unit charge across a complete circuit. To move a unit charge across a complete circuit. So you need to understand the difference. The difference is potential difference between 2 points, but electromotive is to move a unit charge across a complete circuit. You can be asked about similarities between EMF and the PD. You will say both of them is work done per unit charge, and both of them are measured in volts and also measured using a voltmeter. We have 5 cells, each of 1.5 volts. So we are supposed to work out the EMF of the battery. So which means since there are 5 cells here, you have to remember that the total EMF will be number of cells times the value of the PD for each particular cell. So in that case, we're going to say this is going to be 5 times 1.5, and if you work it out, you're going to get your answer 7.5 volts. That's the EMF of this cell. Draw an electrical circuit with the following components, and the components we're told is ammeter, thermistor, switch, 2 bulbs in series, and a voltmeter connected to measure the PD across the thermistor. So of course you're going to use standard symbols whenever you're going to do that. So we're going to start with a battery. A battery, remember, is a combination of main cells. So we shall have that. That's going to be our battery there. Then we shall have an ammeter. Remember, an ammeter is connected in series with all components. Then we shall have 2 bulbs which are connected in series as required. After that, we shall have a thermistor. Remember, a thermistor is a type of resistor whose resistance depends on temperature, and that's going to have that symbol like that. So in the event that you are told to connect a voltmeter to measure the PD across a component, remember, it should be connected in parallel to the component. So we shall say a voltmeter will be connected at that point like that. So that's exactly what we are going to do at that point. So don't forget to label your diagram once you've been asked to do that. The diagram below shows an electric circuit, and then we are supposed to calculate the combined resistance for this circuit here, so that we can be able to use the value to work out values. So if you can look at this, we have 2 resistors which are in parallel, so that combination will be 1/6 plus 1/3, and this is going to be raised to power -1. Then we shall say plus 8, the one that is in series here. So if you work it out, you're going to get what? 1/6 plus 1/3 raised to power -1. Then now we shall say plus 8. That's going to give us 10 ohms. This is 10 ohms. Ammeter reading. Remember, we're going to use Ohm's law, and Ohm's law states that V is equals to IR, which means that if we rearrange this formula using the triangle, so we're going to have this as V equals to IR. So since we want current, we're going to say, so therefore the formula current is going to be equals to V over R, and that is going to translate to V is 6 volts. You can see it well seated here, 6 volts, and total resistance we've gotten 10, so this is going to be 6/10, and that's going to translate to 0.6 amperes. 0.6 amperes. Don't forget the units. PD across 8 ohm resistor. So what we need to remember is that current that is passing through this resistor is basically going to be what? Current is going to be 0.6 amperes. That's the current that is passing through this resistor. Then for you to find potential difference is voltage. So this is going to be V is equals to IR. So that's going to be calculated as V equals to IR, and that's going to translate to 0.6 times resistance, which is 8. And if you work it out, you're going to get your answer exactly 4.8 volts. So in the event you are asked to calculate the PD across n of the resistors here, because these two are in parallel, they are going to have the same voltage, and the voltage that they are going to have will be 6 minus 4.8, and that is going to be, this resistor here is going to have actually 1.2. so the voltage across this one is 1.2, and also the voltage across this one is 1.2. so in the event a voltmeter is connected here, the value it's going to read here is going to be 1.2 volts, because these two are basically in parallel. They are going to have the same voltage, because since this has taken 4.8, then the voltage in this section and the voltage that you have anywhere here is going to be, if we add them, must give us the 6. So that's why I said this section will be 6 minus 4.8. So that is exactly what you're supposed to do in that particular question. So moving to another area that is quite essential that you really have to understand is the question to do with potential dividers, whereby you can be asked to calculate V in or V out. So in this case here, we are told that the V in, this is V in voltage input, and this is the V out we are trying to calculate here. So to calculate the voltage that is getting out through this resistor, of course, we are told is 5 ohms. We are told this is a resistor of 5 ohms because it's mentioned in this value here. Yeah, so it's mentioned here. So which means that we can say V out. Remember this formula already, you've done it in IGCSE level. This is going to be R1 over R1 plus R2 times V in. So you realize that this is going to be, now R1 is where the voltage is being tapped from. This voltage is being tapped from this section across this resistor. That's where the V out is being tapped from. Okay, so we are going to say now is 5 over the sum of these two resistors. 5 plus 10 is going to give us 15. So if I don't know why it's taking long to sense this. Let me try whether now it can work out. Let me just shut it down. Then I turn it on so that we can be able to see whether it will work. Okay, so that's the point that we are in. So this is going to be R1 over R1 plus R2. Our R1 is where the voltage is being tapped from, all the where the voltage is, you see the connection is across this resistor. So we're going to say 5 over 5 plus 10, 10 is going to give us 15. Then times the V in, which is 30, which is going to be equivalent to, this goes twice, so this is going to be 10 volts. So the voltage that is going to get out is 10 volts. The purpose of a potential divider is to divide the voltage into different proportions, and that is done using a voltmeter. Two resistors, yeah, 12 resistors. Explain the change in V out if temperature of the surrounding increases. So you can see here, what we have here is a thermistor. If temperature increases, resistance is going to decrease. And if resistance decrease, V out will decrease. So we are going to say as temperature increases, resistance of the thermistor decreases. So since V equals to IR, and since resistance has decreased, so V out decreases. V out decreases. So basically that's exactly what you're supposed to do at that particular section.